Welcome to Tutoring with Mr. Schmidt. So we are looking at our mixed nomenclature practice worksheet, and I'm in tutoring right now, and I have a few students that are wanting to go over, it's a very odd choice, but multiples of 5. So we're going to just do that. That's what they randomly chose, and it wasn't like it was assigned by their teacher or anything like that. So we'll start with lithium oxide. And so the first thing we have to do, we're just really looking for the formula on this worksheet, but if your teacher assigned you, something crazy like to calculate the molar mass, then we'll just show you how to do that as well. So if you have lithium oxide, you first should recognize that this is a metal. Lithium is a metal. And if you have a metal in your compound, then you will have an ionic compound. And if you have an ionic compound, what do you have to look at? That's right, the charges. So you're going to go to your periodic table, and you're going to find the charge of lithium. So you should get your periodic table out. So get your periodic table out, and you find that lithium has a 1+ charge, and that oxide has a 2- charge. And do the sum of the charges equal 0? Well, of course not. So we do a little switch. We have 1 oxygen and 2 lithium ions, 1 oxide ion, 2 lithium ions. And so that will make the sum of the charges equal 0. So we rewrite that as Li2O. Now, if we wanted to know what is the mass of 1 mole of lithium oxide, so the mass of 1 mole of Li2O, or 6.02 times 10 to the 23rd, whoa, my goodness, formula units of Li2O. And the reason why we say formula units is because it's an ionic compound. If we were talking about a molecule, we'd say we have 6.02 times 10 to the 23rd molecules. But lithium oxide is an ionic compound, and we refer to that as a formula unit. So we have that many. So what is the mass of that many formula units? Well, we can get this by going to our periodic table. So the first thing we do is we list what is in lithium oxide. We have lithium, we have oxygen. And how many lithium do we have in lithium oxide? How many are we showing? 2. Thank you very much. And how many oxygen? 1. Are you seeing that? 2 and 1. You see where we're getting at? Now go to your periodic table. Look at lithium. What is the mass that is given for lithium? What is the mass that is given for lithium? Okay, so yes, you're right. Lithium is 6.941 grams per mole. And oxygen is what? We're looking that up? 15.999 grams per mole. And so you simply multiply. What's 2 times 6.941? This is super easy. 6.941. Get a calculator. And we multiply that times 2, and we should get 13.882 grams per mole. And I'm really good at multiplying by 1. I rarely use a calculator when there's a multiplication problem that involves the number 1. But some people, they need it. So if you're those people, then use it. And so what you should get here is 29.881 grams per mole, and that's of lithium oxide, Li2O. So if I had 29.881 grams of lithium oxide, then I would then I would have 6.02 times 10 to the 23rd formula units. And so that's all there is to that. So you have two parts to your answer if you're in Mr. Gilliland's class. One is the formula, and the next one is the mass. Those are your two answers right there. All right. All right, let's look at number 10, ammonium cyanide. What's in ammonium cyanide? We have an ionic compound, a molecule, an acid. What do we have? What's eliminating this as a molecule? Yeah, there's no prefixes. If there's no prefixes, probably going to be an ionic compound or an acid. And it doesn't say that it's an acid, so it's an ionic compound. So we have to look at charges. So you find ammonium on your polyatomic ion sheet, and you'll see that it says it's NH4 1 plus. And you can find cyanide, which is CN 1 minus. And so the sum of the charges there already equals 0. So you have NH4 CN. Now you want to know what is the mass of 1 mole. All right. So what's in ammonium cyanide? You have nitrogen, hydrogen, carbon, and nitrogen. Whoa, we got nitrogen listed twice. What can I do with that? I don't need to list nitrogen twice, do I? Let's not do that. What are we going to do about that? We're going to say we have nitrogen, hydrogen, and carbon. And how many nitrogen do we have? 2. Instead of listing it twice, we just say we have 2 of them. We have 1 here and 1 here. So how many hydrogen? 4. And how many carbon? That's right, 1. So now you go to your periodic table and you multiply this times the value you see on your periodic table, which is 14.007 grams per mole. This is 1.0079 grams per mole. And this is 12.011 grams per mole. And we simply multiply. And we have 2 times 14.007. And you get somewhere about 28.01. And then you have 4 times 1.0079. You get something like 4.03. Let's just go with that. And then you got the next one, which is 12.011. So you add those up. You add those up, you will get, and I encourage you to use a calculator and add these up because it's highly possible that I don't add them up correctly or I make a mistake on the video. And I'm encouraging you to use a periodic table and a calculator while I'm doing this. So be checking my work. Obviously the steps are there. It's just a matter of whether the calculation is correct. I'm pretty certain they are, but check it anyway. Check along with your calculator. See if you don't get 44.051 or something really close to that. All right. If you got 44.048, don't worry about that. That's the answer. You got the right answer. As long as you're really close to 44.051. All right. Let's go to the next one, number 15. And we may just stop right here with number 15. Well, we may skip to number 30. I want to do number 30, I think. No, we don't need to. We'll stop at number 15. So oxygen difluoride. There's a lot of people that are having issues with problems like this. And what they're trying to do is use charges to solve the problem. And you shouldn't be doing that because you see that it has a prefix di, which tells you this is a what? Yes, it's a molecule. And in a molecule, you will never look at a charge. So all you're going to have to do is just list what you see. You don't see the prefix on oxygen, so that means there's only one. And then it says difluoride, that means there is two of those. So there's your formula. Without doing any charges, you don't need to, because it tells you how many in the name. And so now all you have to do is list what's in oxygen difluoride, and that is oxygen and fluorine. And there's one of these and two of those, multiplied by the mass you find on your periodic table, which is also called the molar mass, 15.999 grams per mole. And fluorine, which is, oh my goodness, 18.998 grams per mole. And so here we get 15.999. I'm running out of room. And then 18.998 times 2 is 37.996. So you add those two values up, and you get 53.995 grams per mole. And that is the mass. 53.99 grams are for every 1 mole. And so two things that you need to have. You need to have your formula correctly, and then secondly, your mass. And if you don't have the right formula, you will not have the right mass, without a doubt. So be using your periodic table to help find the charges that you need when you have an ionic compound, so that you develop the right formula. And then from there, use your periodic table to get the mass of each element that's found in that compound. And then you just simply add those up. So hopefully this helps, and I wish you the best of luck moving forward. If not, please come see me at tutoring every Tuesday, Wednesday, Thursday. I'd be glad to help you. And please tell your friends.